Around. So next I'd like to introduce Russ White, who's going to talk to us about, that is going to work, yeah, about open source routers.
Stuff.
There we go.
Stuff. All right. Hey, it says Q instead of clue. I thought somebody left me a clue up here. I need one of those. So this is about the state of the open source and disaggregated ecosystem. Parts of this are going to be open source. Parts of this are going to be commercial stuff, and that's okay. I'm Russ White. I work for LinkedIn. This first slide is disaggregated chocolate chip cookies, in case you're wondering, because I think we should all do everything disaggregated. So first of all, I want to start with a kind of an overview of the models that I'm talking about here, because some people may not be familiar with them. In SDN, of course, you have a controller and you have a bunch of network devices, and essentially you have this API that connects the controller to the network devices. In Open Standard Control Plane, you have the network device, and then you have an open standard control plane like BGP or OSPF or ISIS that is then running on all those devices and does all the interconnections, and you rely on something like the IETF to build those things. In an open standard, in a disaggregated model, what I call a disaggregated model, is you actually have the network device, you have some sort of open source or commercial NOS that you're using on that network device, but it's separate from your control plane. So your open standard control plane may or may not be a separate application that's running on top of the open source of the commercial NOS, but it allows you to make your control plane decisions separate from your NOS decision. And it's this third model I kind of want to talk about, because that's kind of the area I think that's pretty interesting right now, is what the sources for those NOSes and control planes are, and those white boxes and or bright boxes or whatever you want to call them. So this is just a chart comparing the three. SDN potentially is lower cost. The big insistence from my perspective is that this is not about saving money. White box is not about saving money. Disaggregating is not about saving money. It's more about aligning your technology with your business, because the network can be considered either a strategic advantage or a tactical advantage, or it can be considered a cost center. And if you consider your network a cost center, then probably you don't want to disaggregate. You probably want to focus on driving your vendor costs down. If you're more concerned about figuring out how to shape your network more to your application, and of course, the hyperscalers and web scalers are kind of leading the way in this realm, then you really want to think more about white box, SDN, and disaggregation. So let's talk a little bit about the disaggregated model and think about some of the different components you would need to build or to purchase or whatever, put together like a bunch of little toy blocks, an entire system. So you start up here at the top, you have a routing stack. Of course, you need some sort of a control plane. That's going to contain BGP, ISIS. It's going to contain a RIB to manage the routes and to do arbitration between the various routing protocols. It's going to have to contain a hardware abstraction layer. This is actually going to talk or connect the RIB to a forwarding ASIC. Then you're going to have a kernel, and of course the kernel is just going to run memory management and things like that. And one thing you have to think about in this area is that when you do a ping or a trace route or whatever, those are kernel applications, so therefore the kernel needs to know about the routes coming out of the RIB in some way so that you can actually make those applications work. Then you're going to have what I call a platform abstraction layer. This is going to spin the fans, turn the LEDs on, turn the LEDs off, change the color of the LEDs, do all that cool stuff, so when you bring visitors into your data center, you have a way of making your LEDs flash green or red or whatever you want to as they're walking through, make them all blue or whatever. Then you have your forwarding ASIC, which we're going to talk about some of the providers of those. Then you have a PHY, which is going to be like your physical interface to the box. And then down there at the bottom I have ONI. ONI is basically a bootloader that you can use. It's an open source kind of open project that you can use that's being worked on currently to allow you to boot boxes and do all the platform abstraction layer stuff pretty easily. So there are a couple of different options here when you're looking at doing disaggregation in this field or in routers. Of course, you can always do the single appliance, what I call the appliance model, which is you can use an appliance vendor's hardware combined with their software. So you're basically buying and racking and stacking a chassis or a 1RU unit, and you're actually buying everything from a single vendor. This is what people like to call the one neck to choke model, and I'll actually talk about that in a minute and whether or not I believe that that really works. Another option is to do open source control planes or open source software on appliance vendor hardware. There are a number of appliance vendors or people I consider big vendors working in this space right now. I'll have a slide later on that. You could use vendor software on top of white box or bright box hardware. You can actually today buy vendor software from some of the major vendors that will run on white boxes. And again, I'll give you some names a little bit later for those. You can do open source software on top of a white box or a bright box hardware. And so these are the different models you can get into when you think about disaggregating. I would say the biggest issue in this space is to decide which pieces you want to own internally, which pieces you want to outsource, and what you actually want to work on. So for instance, you may say, I'm not a hardware company, I don't want to roll my own hardware, but I can see the value of owning my own control plane or using an open source control plane that I can tweak. In that case, you might go to an appliance vendor, a standard vendor, and buy hardware with support, and then rely on open source control planes to solve the rest of the problem. On the other hand, you may say, my real concern is in saving money on the hardware side, on the CapEx side. So what I'm going to do is I'm going to go to a vendor and buy my software, but I'm going to buy my hardware from whoever I might be able to buy it from. We can think of different models in the PC market that do the same sort of thing, right? I can buy a Dell or a Lenovo and run Windows on it, which is buying vendor software with theoretically white box or bright box hardware. Or I can go the other way and I can buy a Dell and consider Dell my vendor, or a Lenovo or whoever else, HP, it doesn't matter, and I can run Linux on top of it. So those are the two types of models we're talking about there. So there are all sorts of different ways of doing this. The main thing is deciding what you want to own and where you want to own it. So let's talk about white box and bright box. What you have to do is you have to start with chipsets. And there are a number of companies making chipsets out there right now. Broadcom, Barefoot, Cavium, and Mellanox are the four that I chose for the slide. There are others. I have some others that are talking to me right now that I'm trying to figure out more about what they're doing. These folks supply hardware chipsets not only to the major vendors, they also supply them to white box people as well, like Delta and Alpha Networks, QCT, Acton, Solistica. Believe it or not, you can buy what is effectively white box from Cisco, Dell, and Juniper as well. So if you know the right people to ask and you know the right way to go about doing it, you can buy what is effectively white box or bright box from them as well, and they'll even provide you with tax support and whatever else you need. So let's talk about some vendor software stacks. There are a number of these out there as well. Of course, there's 6Wind is producing a version of Linux that has its own routing stack on it. And I'll actually talk about routing stacks separately because there's a lot of interesting developments in the routing stack area that I want to spend a little more time talking about. There's always Cumulus Linux, which is an interesting choice if you're trying to disaggregate and buy your hardware from one company and your software from someplace else. Juniper has a version of Junos that will run on other people's stuff. There's LabN. Cisco actually has some projects underway, or perhaps already announced, I haven't really kept up very well, running versions of XR and some other things on white box. RT Brick is doing some interesting stuff in this space. Dell has OS 10 or OS, I guess it's OS 10, which came out of the Force 10 acquisition, which they are working with SnapRoute and several others, and SnapRoute is on there as well, to build an open source network operating system around the OpenSwitch, the old OpenSwitch community. So SnapRoute as well is in that community, and then Big Switch, of course, has their own OS that they're working with right now. There are others out there. Again, I'm just trying to give you a sample of what's out there. If you have specific questions about a specific vendor or somebody you've not heard of, feel free to email me, and I'll tell you what I know about them. The platform abstraction layer is actually one of the hardest components to source a lot of times. This is just like drivers on your PC or on your Linux box. What you need to do is you actually need to get this from the hardware vendor a lot of times. And they're going to grab pieces from their vendors of their chipsets and try to pull it all together for you into a single installable application you can use. So you have to somehow figure out how to connect your hardware platform with your OS. This includes, again, things like talking to your PLMs, talking to your PHY chips, talking to your LEDs, running your fans, things like this that need to be done to make the box run. Again, these are normally provided by a hardware vendor or a software vendor. Consulting companies will actually write these. If you go to LabIn or somebody like that and you say, I really, really want a particular chipset in my white box to work with a particular version of Linux or a Linux release or this particular network OS, you can generally write them a check and they will make it happen. The ASIC hardware abstraction is a very complex area right now. There's an awful lot of stuff going on in this space, so you really have to think through exactly what you're doing. So the ASIC hardware abstraction effectively takes your RIB routes and installs them into the FIB or into the ASIC so that you can do forwarding. There are things like SI, Switch Abstraction Interface, which is supported pretty much by all chip vendors. It's a pluggable architecture. In fact, OpenNSL is, the way SI supports Broadcom is it basically uses an OpenNSL plugin in the SI architecture. So this is going to pull your RIB routes in some way, and it's actually going to install them in the FIB. So OpenNSL is a Broadcom-only hardware abstraction layer. So what OpenNSL is basically is a gloss or a thunk layer sitting on top of Broadcom's API. And as people ask Broadcom for more features, they decide whether they're going to include it in OpenNSL or not. P4 is slightly different. It's a Barefoot Networks version of an ASIC or a hardware abstraction layer, a HAL. So what's interesting about P4 is it's actually a programming language. So you run an API and you run an entire development environment that can program the chipset. ASIC-D is SnapRoute's interface to a wide variety of ASICs. This is proprietary to SnapRoute. You have to buy this from them. Switch-D is Cumulus's very similar product. FDIO is based on DPDK, and this is another open source project that I think started out at Cisco and became a general project that you can use. It's largely focused on NICs, however, rather than network switching hardware. So this gives you a slight rundown of some of the projects that are out there. In fact, these are all the ones that I know of. There may be others that are built into like IP Infusion and other projects that are out there. So let's talk about routing stacks a little bit. There are three basic ways you can go on a routing stack. The first is you can go totally open source, which is represented by something like Bird, which is a fairly complete routing stack. It has BGP and OSPF at least. GoBGP, which is a Go version of BGP. I think it was originated by Google and is open sourced. Then you have this blend of open source and commercial. So one of the places there that you can go is SnapRoute. You can go to the GitHub repository, you can download SnapRoute code, and you can compile it and run it. But if you want to pay SnapRoute to support that code, or if you want SnapRoute to do something to that code like add features, you can actually write a contract with them. Cumulus is much the same way with free-range routing, which I'll talk about in just a moment. That has its own set of slides. There are commercial versions, which are like IP Infusion and Cisco and Juniper. IP Infusion will sell you a complete routing stack included in their NAS. Cisco will, and so will Juniper. Free-range routing is a newish project. It was forked off of Quagga. And so this is something that is 6 months old, 7 months old. Last ONS, free-range routing was actually brought into the Linux Foundation in a way where it cannot be controlled by a single company. It's being supported right now by Cumulus, Big Switch, Volta, 6Wind. You can read the list. It's a huge list of companies that are actually supporting free-range routing. All of these companies are not only supporting free-range routing commercially, a lot of these companies actually have coders working on features. And I'll give you a sense of some of the feature in here, but the big complaint that I've heard out of people I've talked to about free-range routing a lot is, well, there's so many features going in and there's so many commits. We can't actually keep up with the code changes that are going on. because there's a lot going on. ISIS is just being rebuilt. There's a lot of performance improvements in BGP. There's a lot of stuff going on in free-range routing right now, FR routing. So for instance, in Stable 2.0, these are some of the changes that were made. Performance and scale fixes, for instance, the entire BGP scanner was sucked out of the BGP implementation in free-range routing, and it was moved to an event-driven mechanism for doing that, for walking the table when necessary. Add path support is in there, remote AS, BGP hostname support, update groups, which is for your update packing in BGP, next stop tracking, which is part of the business of taking out the BGP walking, the table walking processes, 32-bit route tags. There's a ton of stuff going on in here. There's a label manager going in, all sorts of new features going in, and like I said, ISIS is being rebuilt. Of interest as well for anybody who really cares, EIG ERP is currently being built for free-range routing. Babel is actually in and being worked on. This is a very broad set of features and stuff like that. Okay, free-range routing version 3, next version 3.0, which we're actually in discussion on when 3.0 gets released and what is included in 3.0, but here's a lot more stuff in that. Large communities, EVPN partial. There's a lot of EVPN work going on right now in BGP. Like I said before, ISIS is pretty much being rebuilt. Currently, the SPF backout stuff is being added. Authentication is being added to OSPF v3. There's a whole parser rewrite going on. There's actually an entire API rewrite going on between Zebra and the routing protocols. So there's an awful lot going on right now in free-range routing. And I would suggest that if you are looking in the space of open source routing stacks, that free-range routing should be on your short list of things to look at, not only to play with and stuff, but to actually implement. We're talking to OpenBMP and to various other people as well about getting new features and new stuff pushed in here. So what's different about free-range routing is that there is actually a methodical vetting of submissions. The way the process works is the maintainer who allows the code or commits the code from a pull request, this is all Git-based, cannot be from the same organization that actually did the pull request or wrote the code. There's a lot of rules around making sure different companies and different organizations are working in it. So there's a maintainer and steering committee. I'm a maintainer and also on the steering committee for free-range routing. The common assets are held in trust by the Linux Foundation as well, like the logos and things like that. You can get it by a binary package. There's a snap package available now. 2.0 in the stable channel is available, and 3.0 is available in the beta channel. There are Debian and Ubuntu Red Hat packages coming soon. We're working on packaging around this right now and how to manage future packaging requirements. And there's some pointers to the source if you are interested. All right, so now at this point what I want to do is turn my attention a little bit to some architectures. And so I've given you an overview of the space and what's out there and the components that you need to make this work. So now let's look at some of the architectures that are out there and try to get a sense of how some of these architectures, open source and commercial, are actually solving these problems and supplying these things. So Open Network Linux is one of the network operating systems that's completely open source. You can just go to GitHub, download repository, make modifications, hack on it, compile it, and deploy it. Open Network Linux tends to be more of a framework than a complete application or a complete NOS that you can download and use. You have to combine it with something like free-range routing or Quagga or Bird or GoBGP to give you the routing stack. It does, the major component of Open Network Linux is the major components of the Open Network Platform APIs and the Open Route Cache. And the Open Route Cache is actually this piece that mitigates between the kernel calls that do route installs and OpenNSL, SCI, and other things in there that you can use as your ASIC interface. So Open Network Linux is one of those options that's out there. I don't see a lot of people using ONL right now. It's a pretty neat platform. I've played with it a little bit, and it is usable. Cumulus Linux, of course, is a commercial version. It's commercial/open source. Almost everything in Cumulus Linux is downloadable off of GitHub except switched. So you have to buy switched from Cumulus, but pretty much everything else is out there. They have a slightly different architecture in that they're very focused on orchestration and automation. So they have an entire piece around orchestration and automation that integrates VMware NSX, OpenStack, Chef, Puppet, Collect-D, and all these other ways of getting into the system. As a matter of fact, the CLI itself in Cumulus Linux is kind of an add-on that's not, they're really focused on the automation side of things. They're also very focused on BGP. Cumulus Linux is currently using Quagga. They are switching to free-range routing in the very near future, so when you download or install Cumulus Linux in the near future, free-range routing will come as the default mechanism for a routing control plane. Like I said, switched is their thing. Switched actually talks directly to the Broadcom API and other things so that it will run on top of a number of different ASICs. SnapRoute's architecture is a little bit more complex. They are focused more on having a single database through which you can get to everything. And they're using Thrift RPC as their primary connection point to get between things. So they actually have a REST API or a REST config module that talks to CLI, netconf, Ansible, Chef, Yang, all these other things, and pushes it through a process called config-D. Config-D connects through RPC, through Thrift RPC, to talk to each of the protocols. So the SnapRoute version of BGP actually uses the Thrift RPC interface to get its configuration and stuff out of config-D. So when you have a CLI, it actually talks to the REST config and talks to config-D through Thrift RPC to get to everything else. And again, you have another Thrift RPC that actually connects everything that generates information that the ASIC is going to care about for a forwarding table down to ASIC-D. Then ASIC-D can talk to OpenNSL, soft switch, vendor plugins or SI or whatever and talk to the ASIC. Sonic is Microsoft's open source NOS that, again, you can download it off of GitHub, compile it, and run it. It uses a bit more complex modular format or layout. It is primarily focused around the Sonic-based things at the bottom, a database and what's called SWSS. And SWSS is kind of the centralized database for a lot of different things in Sonic. So this is kind of an overview of the architecture of Sonic. You have network applications, they talk to AppDB. AppDB and SciDB actually work within an object library. Sonic is Sci native, so it uses the Sci interface to talk to the ASICs, which means you can use a pluggable OpenNSL or P4 or whatever you want to, but it actually uses persistent Sci objects to do stuff. There's an orchestration layer that sits in there that can allow you to translate between apps and the Sci objects, and this all lives within the Switch Services SWSS module. Sync-D actually uses, polls or checks SciDB for route updates and pushes them through Sci down to the ASIC or through whatever switching module ASIC that you happen to be using. So that's kind of the Sonic layout. So here are some challenges. First of all, in the disaggregated world, you don't get one neck to choke. Now, I don't know, not many of you probably know my history very well, but I worked in Cisco TAC and escalation for many years. And I can tell you that the one note, my opinion anyway is the one neck to choke idea is actually not what you think it is. It's also known as a single point of failure. It's also known as my vendor makes all my architectural decisions for me. It's also known as the neck may sometimes disappear and not do what you want it to do because the neck has other customers besides you. So honestly, I don't think that the one neck to choke model works in large providers, whether it's hyperscale, web scale, or whether it's a transport model, either way. So I don't buy the one neck to choke argument. Market challenges. This is an immature market. You can see there's a lot of stuff going on. The slides are beautiful, but you can't compile the slides and run them, right? So your mileage may vary when you actually download this software and try to compile it. It may take a lot of work to get involved in this. There's a lot of vendors and there's a lot of projects. Everything is in flux. Many of these companies are smaller. There are financial issues in some cases and maybe not in others. Projects are based on small communities. Routing is a small community. Okay, routing is a very small community overall. It's very hard to get people involved in open source routing projects to participate. The skill set is often a unicorn situation. How many people do you know who know C code, can run Git, can actually compile the code and install it and configure your network or run Ansible to run your network, or Puppet or Chef or whatever? It's a very unicorn skill set right now. I think that this will change over time, personally. I think the skill set is growing rather than dying. But you've got to be a Unix head, you've got to be a coder, and you have to be a network engineer. So it's kind of a hard skill set to fill. You can't just be a CLI vendor or a vendor jockey. You have to be full stack. Again, going back to my original argument, for me, the whole idea is that I'm very concerned about integrating the business with the network in a way that makes the network something more than a cost center. But this means that you have to understand the applications as an engineer and the business in a way that allows you to do that. Again, unicorn skill set. Hardware challenges. Route count is low on a lot of these hardware platforms right now. Queue depth and buffering is variable. Label and position depth is very small in a lot of these things. If you're planning on deploying segment routing on top of these, you have to be very careful about your label stacks and what type of support you're going to get out of vendors in these areas. You need to do a lot of research on cost versus benefit analysis and a lot of research into what you get for your money in the silicon support area before making a decision. Project and vendor overlap. Most ASICs are supported by most every option supported here. You can use SI and pretty much be certain that your ASIC is going to be supported. Fans, LEDs, and system chipset are a very different order. Be very careful about asking about the hardware abstraction layer and platform support when you're playing with this. We ain't got no features, okay? The features are building, but my argument is part of the problem with network engineering in the world today is that we love nerd knobs. They're like our Linus comfort blankets. We love our nerd knobs. And we will throw nerd knobs at every problem in the world rather than actually doing real engineering and fixing the real problem at hand. So I actually consider the lack of features a positive thing for making engineers grow up and do the right thing and actually do network design and the hard work of really running a network. There's no tech support unless you buy it. You've got to be an educated consumer. If you're going to play this game, you need to participate in open standards, and you need to pay attention to what's going on in the projects you're relying on. Much of the APIs are under NDA. And again, if you're going to play in the open source world, I would encourage you heavily to be a part of the community. So that is the entire presentation, and we're back to disaggregated chocolate chip cookies. If anybody would like a copy of the presentation or would like to chat about it, I'm very easy to find. I'm not going to give you my email address. So, but feel free to email me if we have any questions. Jump up to the mics and yell at me or whatever, or feel free to contact me offline or to find me. I'll be hanging out a little bit around NANOG for the next couple of days. I left you with 2 minutes early. Look at that. That's because I talked so fast. My record is 95 slides in 15 minutes.
It's like 2 words per slide.
2 words per slide.
Thank you so much. That was great.